Good evening, everyone. Welcome to this Embedded System Design Masterclass series. I warmly welcome you to the session. Thanks for coming and thank you for your time. I would also like to thank the Andhra Pradesh State Skill Development Corporation for their support for this program. So today is day 21. We have still 9 more days to go. And today, this week, we will be covering up the PIC architecture. PIC microcontrollers from Microchip company. And today, we will be covering up the introduction to PIC architecture, like what are the families on PIC microcontroller series, and what are the pin details on pin descriptions of PIC 16F877A. We will be covering a PIC 16F877A series on this 5 days workshop, on this 5 days series. So today will be of the introduction part to the PIC architecture, and tomorrow we will be covering up the embedded system design using PIC microcontroller and how to create a project and download the program on PIC microcontroller. On day 3 and day 4, we will be covering up the LCD, UART and motor control applications on PIC microcontroller. So the project will be on motor control applications on PIC microcontroller. So today we will be covering up the introduction to PIC, the families of PIC and pin details and descriptions and peripherals, what are the peripherals available on the PIC microcontroller and the compilers and registers. Okay. So these are the things which we are going to learn today. I'll give you a short introduction about Pantech and about me and an announcement, and then we can go for the session. Okay, Pantech. Pantech was started in the year 2004. We basically manufacture embedded motherboards like microcontroller boards, DSP boards and FPGA boards. We do manufacture a lot of lab equipments and sensors. If you want to know more about our products and services, just log on to our website pantechsolutions.net. Okay. About me, my name is MK Jivarajan. So I have been explained for this for the past 20 days. So I'm going to skip my introduction. An announcement, the link will be available at 9 p.m. If you don't find the link on the description box, you could get it from the chat box, and the link will be valid for more than 2 hours of time. So you could you could post your attendance even after the session. So minimum attendance required for an e-certificate is 27 days. You may get 1 or 2 days waive off on those 27 days. Okay. For internship candidates, no need to fill the attendance form. And you could access through LMS portal. So we also have 30 days internship, like the batch 5 internship. We have started the batch 5 internship from today. You will be getting 30 days of video coaching lessons, which will be available for 6 months duration, and weekend live Q&A sessions for 6 months, and digital workbook for each microcontroller will be available, an internship certificate, 10 plus projects, sample resume, and get support through dedicated forum, and get PPT download for all 30 days in PPT format. Okay. You could download the source code, you could download the schematics and private WhatsApp group access. So all this will be available at 590 rupees. So if you would avail the internship, if you want to avail the internship, you could join the internships. It's open. The batch 5 is open. So let's start the session. We'll start with the session with the mindset lesson. So today's lesson is about life is a mirror. Life is a mirror. You see what you are. Okay. So what you see is what you think inside. If you see a lot of positive things outside, you are positive. If you see a lot of negative things outside, then it means you have negative inside. Okay. So you attract what you think all day long. So if you think about success, you will get success. If you think about failure, you will get failure. Okay. So what you think is really matters. So if you think everyone is cheating you, it means you have to change your inner feeling. You have to put it in a positive way. So the first thing is change happens inside first, within. The change should be happen within. Then you could see the change on the outside world. Okay. So life is a mirror. You see what you are. This is a lesson which I'd like to share with you today for this series. Let's go for the session. So what is PIC? Okay, PIC stands for Peripheral Interface Controller. and it was coined by microchip technology. This architecture, PIC architecture, is a proprietary architecture from microchip technology. Like you have 8051 core. Core means like it is an architecture. Okay, core is the in the internal architecture is called core. 8051 core, PIC core, ARM core. Okay, so microchip has its own core. Like PIC is its own core. It has different families on PIC microcontrollers. It has low end range, mid range, and high end range of microcontrollers. I will show you like what is on the upcoming slides. I will explain you like what is low end range, what is mid range of microcontrollers, and what is high end range of microcontrollers. So PIC stands for Peripheral Interface Controller, and it was from the company called Microchip. Okay. So PIC, it has only 35 instruction set. If you the assembly instruction set is only 35 instruction set, very small number of instruction set. Like on the olden days on 2000 in 1990s and 2000s, like they used to write the program only on assembly language. Still, lot of companies or they used to practice on assembly language for optimization. Okay, so it has PIC has very less number of instruction set, only 35 instruction set, which you could learn it very easily and you could write the code. And it can operate up to 20 megahertz frequency. The operating voltage should be between 4.2 and 5.5 volts, like the 5 volts power supply. Like PIC 16F8778 does not have an internal oscillator. Okay, so the maximum current each port can supply is 100 milliamps. So PIC 16F8777 has come with 4 different types of packaging. It is available in dual in-line package, 40 pin DIP IC, and you also have 44 pin PLCC, plastic lead chip carrier, and 44 pin TQFP, thin quad flat package, and 44 pin quad flat package. Okay, QFN package, quad flat package. It has total number of 40 pins, and out of this 40 pins, like what we are going to see is a 40 pin DIP IC, and in this 40 pins, 33 pins can be used as GPIOs. Okay, 33 pins can be used as GPIOs. So this is the introduction of PIC. It's from a company called Microchip, and it has very less instruction set, only 35 instruction set it has. Can operate up to 20 megahertz frequency. What I'm talking about is PIC 16F8778. Okay, the operating voltage is 4.2 volts to 5.5 volts, and PIC 16F8778 does not have an internal oscillator, and the maximum current the port can have is about 100 milliamps. Okay, and it is available in 4 different IC packaging. Like it is available in 40 pin DIP package, dual in-line package, and plastic lead chip carrier, 44 pin plastic lead chip carrier, and 44 pin thin quad flat package, and 44 pin quad flat package, QFN package. Okay, so it has 40 pins. Out of 40 pins, 33 pins can be used as general purpose input and general purpose output. So coming to the features of PIC, it has 8 KB of flash program memory, and 368 bytes of data memory, and 256 EEPROM data memory, and it could support 15 interrupt sources. It has in-circuit programming, serial programming, so that you could program a serial program, and 3 internal hardware timers. It has hardware timers for capture, compare, and PWM for PWM modules. It has 8-channel analog to digital converter, and built-in USART for serial communication, universal synchronous asynchronous receiver transmitter for serial communication. It has 5 digital ports. Okay, 5 digital input output ports of up to 22 lines. Okay. So coming to the architecture, PIC architecture, it uses the Harvard architecture. Like basically there are 2 types of architecture. One is the von Neumann architecture and the Harvard architecture, which we have covered up in the previous sessions. I will give you a small recap. In von Neumann architecture, the CPU is connected to the program memory and data memory via a same bus. Okay, so it could either fetch program or it could either fetch data. Whereas in Harvard architecture, The CPU has been connected to the program memory by different bus and data memory with a different bus. So since it is different, it could have different bus width. The program memory can have bus width of 12 bits, 14 bit or 16 bit. Okay, whereas the data memory can have 8 bit. So it could simultaneously fetch program memory, program data as well as the data memory. It could simultaneously fetch. Okay, so it has separate program bus and data bus and can have different widths. So that's the advantage of Harvard architecture. PIC uses the Harvard architecture and it uses the RISC architecture. Okay, so coming to the PIC families, like it has like a 4 family range, like baseline, that is the low range and the mid range, the enhanced mid range and the advanced architecture. Okay, these are the families like PIC 10 series, PIC 12 series and PIC 16 series. We are going to see PIC 16 series. In that we are going to see enhanced mid range, PIC 16F triple X, PIC 16F 877. Okay, so the F stands for the flash programmer memory. C implies, for example, PIC 16C series. C implies EEPROM program memory. If it is a flash program memory, flash is non-volatile and it could be erased any times. Like EEPROM is also non-volatile, but both are different. Like the operation is different and the structure is different. The way the EEPROM stores and the flash stores is different. Okay, and LF stands for low voltage operation. PIC 18LF series. Okay, so the program memory for baseline is 3 KB, for mid-range is 14 KB, and for enhanced mid-range is 28 KB, and for advanced range is 128 KB. Okay, so for performance, like baseline is 5 million instruction per second, whereas for mid-range it is 5 million instruction per second, whereas for enhanced mid-range it has 8 million instruction per second, and for advanced series it is 16 million instruction per second. If you check the features, you have additional features on mid-range. Okay, like the mid-range and the enhanced mid-range. If you check the mid-range, it has I2C SPI, PWM, UART and 10-bit ADC. Okay, whereas in 8051 it does not have an inbuilt SPI or I2C. Like it has to be like you have to, there is no register for I2C or SPI, but this mid-range PIC microcontrollers has I2C and SPI, whereas the enhanced mid-range has what are the things which is covered in mid-range, plus it have high performance and PWM with independent time space. Okay, whereas the advanced PIC series has control area networks, USB, Ethernet, LIN, CAN and LIN are for automotive applications. Okay, and PLL to PLL clock generation which could boost the clock source. Like if the input clock source is 15 megahertz, you could operate the processor at 50 megahertz by multiplying and by dividing this PLL operations. Okay, you could achieve the clock frequency whatever you want for the maximum. You could, even though the input clock frequency is 50 megahertz, you could operate the processor at the maximum frequency by using this PLL, a phase lock loop. So these are the PIC families. Okay, so coming to the CISC and RISC. So CISC or complex instruction set computers, like most of the CPUs or CISC, like the Pentium 4 processor and the 8051 and 8086 or CISC. Like whereas the PIC is the RISC architecture, RISC and the Harvard architecture. Okay, so it has complex instruction set computers, like many instructions, many addressing modes. Usually takes more than one internal clock cycles to execute. Whereas for reduced instruction set computers, like you have only few addressing modes and executes one instructions in one internal clock cycle. Okay, so that's a RISC architecture. Like PIC comes with RISC architecture. Okay, so what is different in PIC? So high performance, it's a RISC CPU with only 35 nodes of instruction set, Harvard architecture, and it supports pipeline instructions. Okay, and large number of peripherals are inbuilt. If you check 8051, like there is when you compare with the 8051, like it has almost large number of instructions set on the PIC architecture, like the CAN, the Ethernet, the USB, the I2C, everything is there. Okay, so this is the pin diagram for PIC 16F877A and PIC 18F4550. So both are same, I will explain you the pin details. Okay, so MCLR stands for master clear, and master clear I have the detailed explanations on the next upcoming slides for each and every pin. So I just want to show it has two VDD and two VSS. Okay, two supply voltage you have to give VDD and two ground voltage, and it has ports like port A and port E, port A, B, C, D, and E. Okay, so totally five ports. Clock for oscillators. Okay, it has T1 clock for timer, and it supports multiplexed signals. Like it could be used for port A, or it could be used for the channel for ADC channel selection. ADC it supports 8 channel ADC. It could be used as a ADC input. Okay, it has an on chip ADC, whereas in 8051 there is no on chip ADC. You have to interface the external ADC. Okay, PIC has an on chip ADC, so no need to go for an external ADC. And it has RX, you are programming SDO, like I squared, it supports I squared C. Okay, SCL and SDA pin is there. PIC 16 of series 16 of 877 supports I squared C. UART is there, and ports. Okay, interrupts. So this is the internal block diagram. Of PIC 16 of 8778. I have attached the data sheets on the Learn portal. You could also get it from the internet. You just search for PIC 16 of 8778 data sheet. Like on page 7, you will get the block diagram. Just get the block diagram. So you have 5 ports. Port A is only 6 pins. Okay, port A is only 6 pins, like A0 to A5. Okay, and this 6 pins, like it is multiplex. It could be used for the ADC inputs, ADC channel selection also, and TO clock is for timer clock. Okay, for timer pin, like capture pins, and RB. This is for RB0 to RB7 for port B. This is port C. Port B is 8 bits. Port C is also 8 pins, and port D is also 8. Okay, and port E is only 3. It also has multiplex like chip select, read and write for memory. Okay, it has internally, it has power up timer, oscillator startup timer, power on reset, watchdog timer is there, brownout reset, and in-circuit debugger and low voltage programming. In-circuit debugger is for debugging purpose. It's for debugging the purpose. Like you could connect the emulator and you could debug the processor via the software. And brownout reset, like if any voltage dropout occurs, it resets the processor. Okay. And power on reset, like whenever you power on the microcontrollers, it resets the processor. That's power on reset. And apart from this, you have 3 timers: timer 0, timer 1, and timer 2. Okay, timer 0, timer 1, and timer 2, and 10-bit analog to digital converter. 10-bit ADC is there. Synchronous serial port is there. SSP synchronous serial port, and USART is there, and you have comparator as well as the voltage reference. Okay. Apart from this, you have oscillator in and flash memory, as well as the data memory. Okay. So the program counter and the data bus. Okay. So this is the internal block diagram of PIC 16 of 8778. And the first pin is master clear. The first pin on the pin description is master clear. So this master clear, like it resets the microcontroller. Okay, it resets the microcontroller. Like whenever you give load to this MCLR pin, so you have to give a circuit diagram like this. Okay, so you put a 5 volt. There is no reset here. There is no reset. As in 8051, we have a reset pin. Okay, here this MCLR pin acts just like a reset. You have to connect this pin to 5 volt. So whenever you connect the pin to low voltage, when you put a switch and if you press the switch, it will reset the processor. Okay, it will reset the processor. So it is just used to reset the processor. So by resetting the processor, like it brings the program back to the first line of the program. Okay, so by default you have to provide 5 volt to this pin. So when you press this pin, like when you press this button, like it will go low, it connects 0, like so it resets the processor. So that's master clear. It acts like a reset. Okay, so the next is I just explained this. We have 2 pins, 11, 12 and 31 and 32 as VDD and VSS. So I just put a basic explanation of what is VDD, what is VSS and VCC and VEE, so that it could be useful for you for or during the interviews. Like VCC is voltage connected to the collector. Okay, so voltage connected to the drain. VDD is voltage connected to the drain. VDD, voltage drain source, I think. So this is BJT transistor and this is FET. Okay, so VE is voltage which is connected to the emitter and voltage which is connected to the source. So the positive supply voltage is VCC, the negative supply voltage is VE and VSS. Okay, voltage supplied to source, voltage connected to source, and voltage connected to the emitter. Okay, so VCC, like it is voltage collector, voltage drain, I think voltage source. So positive supply voltage VCC and VDD are the positive supply voltage, and negative supply voltage is VE and VSS. Okay, so VDD 11 and 32, it's VDD pins. You have to connect 5 volt there. 12 and 31 should be connected to the ground. Okay, they should be connected to the zero potential. They should be connected to the ground. Okay, so crystal oscillator pin is 13 and 14. So far we have caught up this first pin and the 11th and the 12th pin and 31 and 32 pin. Okay, and the next is the 13th and 14th pin, the clock 1 and clock 0, input and the output. Okay, oscillator 1 and oscillator 2, which you have to connect the crystal oscillator. So this is the circuit where you have to connect the crystal oscillator like 10 megahertz or 12 megahertz. Okay, so which supplies the input to the micro. This is just like in heart. This is the heart of the microcontroller. Like you have to only if you provide the crystal source to the microcontroller, like then it calculates the machine cycle and the insertion cycle based on this based on the crystal frequency. Okay, so this is the heart of the oscillator, heart of the microcontroller. The oscillator is the heart of the microcontroller. So this is the oscillator input. Clock in is the oscillator input, whereas clock out is the oscillator output pin. Like this is the reference schematics which you have to connect, and you have the capacitors. Okay, usually this capacitors will be 22 picofarad or like this, 22 picofarad or 18 picofarad or 10 picofarad like that. So and the next is the port A. Okay, port A, like PIC 16F87 has PIC A has 5 IO ports. Total of 33 pins are used for IO operations. Okay, so the port A, coming to port A, is 6-bit wide and it is bidirectional. Okay, it uses the register like truss A could be used as a data direction registers. Okay, port A is also used for the analog inputs for ADC. So port A is from 2 port A is from totally 6. Okay, 2 to 7. 2 to 7 is port A. AN0, AN1, AN2, AN3, AN3 are the 3, like it could be used for the analog inputs. Okay, and this is for timer. Okay, and AN4 is for again for analog inputs. So RA0, RA1, RA2, RA3, RA4 and RA5. So are the port A. These are the port A pins. Okay, it could be used as a bidirectional, like pin 2. Okay, so pin 3, pin 4 and pin 5 are like, and pin 6. Okay, and pin 7. Pin 7 is it could also, SS stands for synchronous serial port. So or is port A. Port E, the next is port E. Pin 8 and pin 9 and pin 10 is port E. Port E has only 3. It's only 3 bit. Port E is only 3 pins. Okay, port 8, pin 8, 9 and 10. And it could be used for the multiplex functions is read and write and for chip select. Okay, chip select for parallel slave port, for it can chip select. Okay, so it's a 3-bit wide port E. Port C, so for like we have covered up, like 1 to 7 we have covered up, 8, 9 and 10 we have covered up, 11 and 12 we have covered up, 13 and 14 we have covered up, 13 and 14 and 31 and 32 we have covered up. Okay, and next is port C. Port C is from 15 to 26. It's 8-bit wide. Okay, it consists of 8 pins: 15, 16, 17, 18 and 23, 24, 25, 26. Okay, RC1, RC0, RC1, RC2, RC3, RC4, RC5, RC6 and RC7. It has multiplus functions, like the same pin 25 and 26 is used as UART for transmitting and receiving. Okay, and for SPA, like for serial peripheral interface, like SDA, SDO is here, like and SDA, it also uses I squared and SPA modes. The same pin is also SPA modes, and pulse width modulation, like the capture compare is the pin 17 pins. Okay, so this is port C. And port C, like it's bidirectional, like the direction registers are truss C. Like this we will be covering up on the next, like the LED blinking code and the LED blinking code and the UART code, like which will be covering up the registers in detail. The next is port D. Okay, port D, like we have a pin 19, 20, 21, 22, 27, 28, 29, 30. So all these pins are port D, like which is again bidirectional input as well as the output port. 1920. So it is 8-bit wide. Okay, it uses truss D for the data direction registers. So port D is used as a data port. And so if you check, like if you check the pin details, like we have caught up port A, port E we have covered up, port C we have caught up, port C. Okay, and port D, like from 19th and 20th and 21, 22 and 27 and 28 and 29. Okay, 29 and 30. Yes, port D, and then we have port B. Okay, port D and port B. Port B, like from 33 to 40, pin 33 to 40, again it is 8-bit wide and bidirectional. It uses truss B for data direction registers. So we will be going in detail into the registers on the LED blinking code and the other codes, LCD codes and like that. So port B is for data transmission, like RB6 and RB7s can be used for in-circuit debugging pins. Okay, RB0 can be used as external interrupt pin, and RB6 and RB7 can be used as in-circuit debugging. In-circuit debugging is for hardware debug. You could debugging is for in-circuit debugging, means like you could connect the hardware as well as you could connect the software, and you could keep the breakpoints and watch points, and you could stop the execution of the program at a particular point, and then you could analyze the registers values and the memory values, and you could check. Okay, so that's the advantage of in-circuit debugging. Okay, so multifunctional pins. So all initially it is better to use a pin with a single functionality, but once you are familiar, then you could use the multifunctional mode. Once you become like expert in programming, like you could go for the multifunctional mode. And most of the pins uses the multifunctional, contains a multifunctional, like it could be used as the digital input pin or a digital output pin, or you could use the same pin as UART or I squared C. It's same like LPC 2148 and LPC 4088. Okay, so it uses the multifunctional. It uses the multifunctional. Is multiplexed signals. So you have to whatever the functions, like through program, you could switch between the different functionalities. Okay, if you want to read the analog signal, you could define it for analog purpose. If you want to read as a digital input or output, then you could define it for digital read to read the digital input and output purpose. So all these are multifunctional pins. Okay, so Coming to the features of PIC 16F877A, other than the GPIOs, like it has the unlock to digital on chip unlock to digital converter module. Okay, so this feature was not in 8051, but it has A to D converter, like unlock to digital converter module. We have it on ARM7, we have it on LPC2, LPC4088, and PIC also we have. Okay, you could get the PIC IC for 140 to 180 rupees, like PIC microcontroller, whereas LPC2148 you will get the chip for 480 rupees, 480 to 500 rupees, like a single chip. LPC2148, whereas LPC4088, it will be, the cost will comes around 800 to 900 rupees. Okay, and it is a quad flat package which needs a soldering station to mount. So this, if you want, the best option is to choose the PIC 16F877A series, which is also available in DIP series. Okay, if for a beginner and if you want an on-chip ADC, then the best option is to choose the PIC microcontroller. Okay, so it has 8-bit ADC module. So these are the pins from 1 to 10. From 1 to 10, like it has 8 channels. Okay, AN0, AN1, AN2, AN3. Okay, AN3 and AN4, 5, 6, 7. Okay, so 2, 3, 2, 3, 4, 5, and 7, 8, 9, 10. 7, 8, 10. These are the pins which you could use as a which could accept the analog inputs. You could directly connect the analog temperature sensor to these pins. Okay, and you could get the acquisition. The resolution will be 10 bit. The ADC resolution will be 10 bit. Okay, it has 8-bit ADC module. Let me check the resolution of the ADC. The ADC resolution is 10 bits. Okay, so you could get it from the data sheets. Mostly you could get it from the data sheets. Okay, it will be available on the features itself. So the first thing you have to do is to go through the data sheets. Okay, so the data sheet will give you the complete information. So 10 bit. So okay, here it is, 10 bit and 8 channel analog to digital converter. Okay, the data sheet will give you the complete features and complete peripherals, like what are the peripherals and features, and the what are the pin details and descriptions on various package. This is SO, this is a PDIP package or a DIP package or SOIC. Okay, small outline integrated circuits and SSOP package, quad flat package, QFN package. Okay, and these are different packages. Okay, so it will give you the device overview and the key features, like what are the features it has, what is the operating frequencies, flash program memory, data memory, EEPROM data memory, interrupts, how many interrupts it could support, like 14, 15, ours is PIC 16F877A, so it supports 15 interrupt sources, whereas PIC 16F876A supports only 14 interrupts. Okay, ports like IO ports, PIC 16F873A, we have port ABC. PIC 16F874A, we have ABCDE. Okay, whereas in PIC 16F877A, we have ports ABCD. Timers is 3, capture, compare and PWM modules 2, serial communications, USOT we have, and serial ports. Okay, serial ports we have, serial MSSP ports, serial ports, and PSP parallel communication, 8 input channels, ADC module. These are the available packages, and all these will be available. Like this is the block diagram. Okay, block diagram, and you could these are the pin descriptions in detail. So you have to go through the pin descriptions in detail here. You have to go each and every details of the pin, like what is the description, what is the pin name, and what is the description, whether it is digital input or external interrupt. Okay, so once you go through the data sheets of 8051, data sheets of PIC 16F877A, data sheet of LPC 2148 and LPC 4088, like you'll get more familiar like the terminologies, and you will be more familiar like how it works and everything. So master clear inputs. Okay, so the next features is timers. It has 3 timers: timer 0, timer 1 and timer 2. Okay, timer 0 is 8-bit timer, and timer 1 is 16-bit, and timer 2 is 8-bit. Okay, so timer 0 and timer 2 is 8-bit, and timer 1 is 16-bit timer. It can also operate in both modes. If timer 2, it is used with pulse width modulation. Okay, capture comparator module, and it could use like these are the pins, like pins of the timers. And EEPROM, like it also has built-in electrically erasable read-only memory, which can be used to store data permanently even if the microcontroller is switched off. Okay, so pulse width modulation, it supports pulse width modulation for especially for motor control, like for to have the varying duty cycle, to it also provides 2 CCP modules, capture, compare, and PWM modules. We can easily generate 2 PWM signals with this microcontroller. Okay, the maximum resolution it supports is 10 bits. And UARTs for serial communication, like it is used to communicate with other devices like other microcontrollers or other PC TTL logic. Okay, so the RC7 pin is transmitter, on RX pin is the RX pin number is 26, and TX pin like which is 25. RC7 and RC6. RC7 is RX pin and RC6 is TX pin. Okay, it's UART, universal asynchronous receiver transmitter. I2C communication, like you have this 18th and 23 pin. SCL like RC3 and RC4 is SCL and SDA. Like you have the serial clock and the serial data for I2C communication. Interrupts, it supports 15 types of interrupts. Okay, 15 types of interrupts. It could support external interrupts from timer 0, interrupts from timer 1, and RB port change, and parallel slave port read or write operations, and AD analog to digital converter operations, and use or receive and use or transmit operations, on synchronous serial port, SSP ports, synchronous serial ports, and capture, compare, PWM, P1, CCP1 and CCP2, and TMR2, comparator, EEPROM write operation, bus collision. So all this can generate interrupts. Okay, so this microcontroller provides 15 types of interrupts. Interrupt sources are there, so you could map the priority. So comparator, it has a comparator module which like it just like an analog signal comparators in electronic circuits, where you could use the analog the analog supply pins, the analog input pins like RA0, RA1, RA2, RA3. These are the analog input pins, where you could use these analog input pins and you could compare the signals. Okay, compare the analog signals. So that is the advantage of this comparator. So like this comparator, like it is not there in 8051. Like you could compare the analog signal similar to the comparator in the electronic circuits. So you could use the RA0, RA1, RA2, RA3. These are the analog pins, input pins, which could accept analog input signals. Okay, which could accept analog input signals. So that's one advantage of PIC. Watchdog timer, like it has the WT is on chip separate oscillator which runs freely. Okay, so watchdog timer, like even if the device is in sleep mode, will work. It will work even when the device is on sleep mode, and it is to wake up the device from sleep mode, as well as any malfunction occurs, like it resets. And sleep mode, like PIC 16F877A can also provide sleep mode operation. During this mode, like it could operate at very low power. Okay, and it draws minimal amount of current. So you have to wake up from sleep mode from interrupts sources like timer 1 or interrupt or UART interrupt or EEPROM write operations and many others. Okay, so PIC or PIC 16F7 also supports sleep mode. So this sleep mode can be used when you operate from when you use the battery operated power supply. So it has brownout detection, like whenever the significant drop in power supply voltage, it resets the processors. Okay, brownout detection and brownout resets. So data memory organization, like data memory partition general purpose registers, like we have two bank like RP1 or the bank select bits. Okay, so I'll show you the data memory organization on the data sheet. So these are the memory organization, like so it has multiple banks. Okay, which contains like we have sub general purpose registers, special function registers like bits RP1 and RP0. We have to use this for on this for selecting this memory. Okay, so it is here. Okay, so these are the registers which is associated with the data memory. Flash program read. Okay, and writing to flash program memory, block writes. Okay, so these are the registers. These are the registers like which we'll be covering up in detail on the next upcoming sessions, like port A register, tris A, tris B, tris C for direction registers and interrupt registers, timer registers, ADC registers. Okay, so bank 0, bank 1 and bank 2 and bank 3, like which has the address as well as the registers here, and special functions registers. Okay, so we'll be going much more detail in the next in the upcoming sessions. On the machine cycle, like it has 4 cycles per instructions, like this is the clock cycle, like the instruction like it supports pipeline, like pipelining like instruction, decode instruction, fetch the instruction, T1 it fetch the instruction, then decode the instruction, and T3 execute the instruction, T4 it stores the instruction, like 4 cycles per instructions. Okay, 4 machine cycles per instructions. Like this is the machine cycle calculation. Like if the clock frequency is 6.144 megahertz, you have to divide the 6.144 megahertz divided by 4. Hence, one machine cycle is 4 divided by 1 is 0.651 microseconds if you use 6.144 megahertz. Okay, so instruction cycle, it's a time taken to complete an instruction. Okay, all instructions in 16F8 are single cycle instructions except the branching instructions. They take 2 machine cycles. The rest of the instruction cycle will take only 1 instruction cycles. Okay, and different types like different types of PIC microcontroller like needs different compilers. Like you have MPLAB XC8C compiler and XC16C compiler, XC32C compiler, micro C compiler, PIC CSS compiler. Like I'll give you the link which you could download the evaluation version and you could install on the tomorrow session. So tomorrow session will be on the embedded system design, using the PIC microcontroller, and how to blink an LED using using PIC microcontroller. So with this, I close the session, and thank you so much for your time. Thanks for coming. Meet you on the next session tomorrow.